Elastic potential energy. GCSE Physics. Long before safety harnesses or modern materials, tightrope walkers crossed huge gaps on ropes stretched high above the ground. Elastic potential energy is energy stored when an object is stretched, squashed, twisted, or bent, as long as it can return to its original shape. How much elastic potential energy is stored depends on two things. First, how stiff the object is. Second, how far it is stretched or squashed. Now we can describe this properly using physics. The equation for elastic potential energy is elastic potential energy equals 1/2 times the spring constant times the extension squared. E equals 1/2 k E squared. The spring constant K tells you how stiff the object is. It is measured in newtons per metre. The extension, E, is how far the object changes shape. It is measured in metres, not centimetres. The extension is squared, which means small increases in stretch lead to much larger increases in stored energy. If you double the extension, the stored energy becomes 4 times larger. If you triple the extension, the stored energy becomes 9 times larger. That is why stretching something just a little bit further can dramatically increase the energy it stores. People understood this long before the equation existed. Take catapults. Twisted ropes or bent beams stored elastic potential energy. Tighter, stiffer ropes meant a larger spring constant. Pulling them back further meant a larger extension. More stiffness and more stretch meant more stored energy, and heavier stones could be launched. That is K and E in action. Now look at a bow and arrow. The bow bends as it is pulled back, storing elastic potential energy. A stiffer bow has a larger spring constant. Pulling the string back further increases the extension. Let's calculate it. A bow has a spring constant of 400 newtons per metre. It is pulled back by 0.5 metres. Elastic potential energy equals 1/2 times 400 times 0.5 squared. 0.5 squared is 0.25. That gives 50 joules of elastic potential energy. All of that energy is stored in the bent bow, ready to be released into the arrow. Now your challenge. A car suspension spring has a spring constant of 20,000 newtons per metre. When someone gets into the car, it compresses by 0.03 metres. How much elastic potential energy is stored in that spring? The answer is 9 joules. From tightropes and bows to catapults and car suspensions, the same physics applies. If something is bent, stretched or squashed and can spring back, it stores elastic potential energy. To practice this properly, use the full set linked below. You'll find a clear presentation, a workbook with worked examples, and self-marking questions so you can check your answers.